In this video, we're going to talk about your basic trig ratios. So we're going to talk about sine and cosine and tangent. When we're talking about these three trig ratios, we're talking about right angle triangles. So before we talk about sine and cosine and tangent, we need to come up with agreed upon ways to label our triangle. So right here is the letter theta. It's a Greek letter, and we typically use this to represent an unknown angle. So if this is the angle that we're looking for, if this is the angle we care about, we're going to label the three other sides based on this angle. The first side to label is our hypotenuse. It's the longest side of a right angle triangle, and it's always right across from our right angle. So if we locate our right angle and we draw a line across, we're going to run into the hypotenuse. Then we can look at the angle that we care about. From this angle, if we draw a line straight across, the side that we run into will be the opposite side. The side that's left over, or the side next to theta, that's not the hypotenuse, is our adjacent side. This labeling would be different if theta was up here. So let's take a look at that really quickly. If instead of this being theta, if this is the theta that we were interested in, let's label it theta 2. This is still our hypotenuse, but now the side across from theta is here. So this side, instead of being adjacent, becomes opposite. And the leftover side, the side that's next to theta, but not the hypotenuse, is our adjacent side. So this one would become our adjacent side. So it really depends on where our theta is, how we label our triangle. Let's go back to our original version here though. So once we have our triangle labeled, we can start thinking about sine and cosine and tangent. These are the three basic trig functions. When we look at these functions are all set up as a ratio of two of the three sides of our triangle. So sine theta is length of the opposite side divided by length of the hypotenuse. Cosine of theta is length of the adjacent side divided by the length of the hypotenuse. And tangent of theta is the length of the opposite side divided by the length of the adjacent side. One thing to make sure is when we're doing any calculations with sine and cosine and tangent, at this point, we want to make sure that our calculator is in degree mode rather than radians. So your calculator should say D or DEG and not R or RAD. We'll talk about radians later in this course, but for right now, we're measuring our angle in terms of degrees. To help us remember these three trig ratios, we can use SOHCAHTOA. So sine, S, is opposite over hypotenuse, cosine, C, is adjacent over hypotenuse, and tangent, T, is opposite over adjacent. So let's look and see if we can figure out sine and cosine and tangent if we're given some triangles. So let's take a look at this first one. Given the triangle below, we need to find sine of theta, cosine of theta, and tangent of theta. Well, here's theta, so let's label our triangle. Here's our right angle. Across from our right angle is our hypotenuse. Here's theta. Across from theta is opposite. And our leftover side, our side that's next to theta, is adjacent. Now that we have this labeled, we can find sine and cosine and tangent. So sine of theta is opposite over hypotenuse, and opposite is 4. Hypotenuse is 7.07. We typically don't write fractions with decimals, so let's just change this into a decimal. And if we do that, it'll be 0.5658. We can find cosine of theta as well. Remember, cosine is adjacent over hypotenuse. So here's our adjacent side, which is 6. Our hypotenuse, 7.07. Again, we typically don't write fractions with decimals. So if we change this into a decimal, we'll get 0.8487. And finally, let's find tangent. Tangent of theta is opposite over adjacent, or 4 over 6. And if we wrote this as a decimal, it'd be 0.6667. We can do the same thing for this triangle here. This time, theta is up in this corner, right? All we've done is shift where the location of theta. So to label our triangle, find our right angle. Across from our right angle is our hypotenuse. Find the angle we care about. Across from that angle is opposite. Next to that angle is adjacent. And again, now that we have these sides labeled, we can find sine and cosine and tangent of theta. So sine of theta is opposite over hypotenuse, which is 3 over 10. And if we wanted to write that as a decimal, we could. It would be 0.3. Cosine of theta is adjacent over hypotenuse, which is 9.5 over 10, or 0.95. And tangent of theta is opposite over adjacent, or 3 over 9.5, which is 0.3158. So that's the basics for sine and cosine and tangent, remembering that when we're doing this, we need to have a right angle triangle. If we don't have a right angle triangle, it doesn't make sense to talk about sine, cosine, or tangent of any of the angles. In the next video, we'll look at using sine, cosine, and tangent to find a missing side length or to find a missing angle.